Good morning, students. Today we're going to be looking at Module 6, Lesson number 5. And today you will be able to factor trinomials of the form x squared plus bx plus c. So what we're doing when we have a quadratic trinomial like this, our goal eventually is to be able to solve this equation. And factoring is one of the main techniques that you use to solve quadratic equations. So we're going to build you up by noticing some of the patterns that happen when we multiply two binomials times each other using the distributive property. And by noticing those patterns, we're going to be able to work backwards so that when we have a quadratic trinomial, we're going to be able to break it down into its component parts. So starting out, let's take a look at the exploration activity. We're going to simplify the following and then answer the questions. And this would be a place where you can pause the video. We've done this topic. You know how to multiply two binomials times each other. So you can pause the video and check your answers after I have multiplied them all out here. So if you paused and you're back, I'm going to go ahead and start with letter A. I've got x plus 6 times x plus 4. I'm going to use the FOIL technique, so I'm going to multiply my first two terms, x times x. I get x squared. My outer terms, x times 4 is 4x. My inner terms, 6 times x is 6x. And my last term, 6 times 4 is 24. And then I'm going to notice that I have these two terms in the middle, and I'm going to combine like terms. My final answer for this one is x squared plus 10x plus 24. Letter B, I've got two subtraction signs, two binomials that are being subtracted, x minus 3 times x minus 5. And I'm going to do the same pattern. First, outer, inner, last, and negative 3 times negative 5, that's going to end up being a positive 15. Combine like terms, I get x squared minus 8x plus 15. Next, I want to pay attention to the fact that I have a minus and a plus. I have a subtraction and an addition. So what's going to happen? I'm going to use the same pattern. First, x squared, outer, plus 4x, inner, minus 9x, last. Negative 9 times positive 4 is negative 36. I still always have these middle two terms here that are going to combine. So I get x squared, 4 minus 9 is minus 5x, minus 36. And last but not least, I've got another subtraction and addition. This time the number I'm subtracting is smaller than the number that I'm adding. I've got an x minus 1 and an x plus 6. So I'm going to see what that does to my result. So I've got x squared plus 6x minus x minus 6. And when I combine my like terms this time, I have a plus 5x as my b term, or my middle term, or my coefficient of x is positive 5. So we always write in standard form, which is descending order of the variable. So it's x squared plus bx plus c. B is whatever's with the x. C is your constant. And so we want to use that information to answer the following questions. Look at the original problems A through D above. What do you notice about the original numbers and the b from your answer? So pause, think, write what you notice, and then I'll tell you what you're supposed to notice is that if you add the original two numbers, to get b. So I had positive 6, positive 4, I ended up with positive 10 in the middle. Negative 3, negative 5, ended up with negative 8. Minus 9 plus 4 ended up with minus 5. Minus 1 plus 6 ended up with plus 5. So Now I want you to look back at the original problems A through D above, and what do you notice about the original numbers and the C from your answer? So remember, C is the constant term at the end. So if you want to pause and see what you think you're supposed to notice. And then what I notice is that positive 6 times positive 4 equals positive 24. Negative 3 times negative 5 equals positive 15. I notice that if I multiply the original two numbers, we get C. Multiply the two original numbers to get C. So when we do something called factoring x squared plus bx plus c, I'm going to say this over and over again. We're going to find two numbers to multiply to get c. And add to get b. So when I'm factoring in example 1, x squared plus 8x plus 15, I am asking myself, what are two numbers that multiply to equal 15? So I'm going to say they multiply to equal 15, and they add to equal 8. So I'm sort of making a table here, and I just want to, sometimes we're going to have to guess a few numbers before we get the right one. So I like to guess a few wrong choices before I get to the right one. So if I want two numbers that multiply to equal 15, I could say I'm going to try 1 and 15. 1 times 15 equals 15. But then when I add them, they add up to be 16. So I know that's not my right choice for my numbers. And I could try a negative 1 and a negative 15, because negative times negative would be positive. But then I would end up with negative 16. So I hope you know where I'm going with this. I hope you see that the only other way to multiply and get 15 is 3 times 5. And when I take 3 times 5, I get positive 15. And then when I do 3 plus 5, I get 8. So that is my correct choice for two numbers that multiply to get C and add to get B. So in this shortcut method, I'm going to create two binomials. Each one is going to have an x, and then I used a positive 3 and a positive 5, so I'm going to have x plus 3 and x plus 5. And now I'm going to go through the same process with part B. We're still doing a teacher-led example, so you can just kind of join along and try to anticipate what I'm doing. I'm going to set up my table, and I'm going to say I am looking for two numbers that multiply to equal 24, and that's a positive 24. If it was negative, I would have to write the negative there. So two numbers that multiply to equal positive 24, two numbers that add to equal negative 11. So 24 has tons of different factor pairs that you could multiply to equal 24. I could do 1 times 24, but then I get 25 for that one. I can do 2 times 12, and that adds up to 14. So I'm a little bit closer to 11 in my 14, but I don't have a negative 11 yet. So I might try a negative 2 and a negative 12, because negative times negative equals positive, and then negative 2 plus negative 12, well, that equals negative 14. So then, and you can kind of see with the factor pairs I'm counting up. I started at 1 and then 2. Now I'm going to try 3. I know 3 times 8 is 24, and 3 plus 8 is positive 11. So my only issue is I don't need positive 11, I need negative 11. So then I go back and I say negative 3, negative 8, negative times negative, still positive, negative 3 plus negative 8, negative 11. And so I found my magical factor pair that multiplies to be 24, adds to be negative 11. So now I can write my factored form of the polynomial. I've got two binomials multiplied by each other, and I've got my negative 3 and my negative 8, or minus 3 and minus 8. So now it is your turn. So I'd like you to pause the video and take a look at the following 4 problems and see if you can ask yourself the question in your head. What multiplies to equal C that adds to equal B? And we'll come back in a minute and check your answers. So letter A, I've got two numbers that I want to multiply to be 30 and add to be 11. So I'm going to try 3 times 10. 3 times 10 is 30, but 3 plus 10 is actually 13. So that's not good. So what else multiplies to equal 30 that adds to 11? I'm going to try 5 times 6. And 5 times 6 is 30. 5 plus 6, oh look there. There's my correct answer choice. So I'm going to rewrite my quadratic as the product of two binomials. In letter B, I'm trying to multiply to be positive 8, add to equal negative 6. So I know 2 times 4 is 8. So 2 times 4, and then 2 plus 4 is positive 6. So if I've got the number right but not the sign, I simply have to go back one more time and say, well, I think negative 2 times negative 4, still positive 8, and then when I add them, that equals negative 6. So x minus 2, x minus 4. And so now this is going to follow like one of the examples in on the first page. I've got a negative and a negative, so I'm going to need two numbers that multiply to equal negative 21 and that add to be negative 4. So I know that 3 times 7 is 21. So 3 times 7, well, that's positive 21. So 3 times 7 can't be my choices there. What can I do to make it equal negative? Well, I can make one of those negative. So negative 3 times 7, now that's negative 21. So that side works. But then I do negative 3 plus 7, and I get a positive 4. So that's not exactly the combination that I need. But remember, if I have the number right but not the sign, I can just do some switcheroo on my sign. So it's going to be 3 times negative 7 is still 21. Negative 21, and now when I add them together I get negative 4. So that's the pair of numbers that I'm looking for. So when I write my binomial, I'm going to make sure my 3 is positive and my 7 has the minus sign. So last but not least, we're trying to multiply to be negative 36, and we're trying to add to get a result of 9. So there's lots of things that multiply to equal negative 36. And I'm sort of noticing from the last one, if I want to multiply to get a negative number here, I better have one positive and one negative. So I'm going to do 6 times negative 6. I know 6 times 6 is 36. So 6 times negative 6 is negative 36. But then when I add those together, I don't get 9. I get 0. So maybe I'll try 4 times 9. So 4 times 9, well, that equals negative 36, so let me make one of them negative. Now negative 4 times 9 is negative 36, so that works. But negative 4 plus 9 is 5, not what I need. So I'm looking to try some other things that equal negative 36, and I'm thinking I could do 1 times 36, but in my head I know that adds up to 37 or a big number. I could do 2 times 18, but once again, kind of adding it in my head, I see that's probably not going to be a very good guess because that equals 16. So really, you don't have to add them all in your head. You can write them down on your table, try it out. You can use your calculator to do the addition and the multiplication, and if it doesn't work out, just keep going And I usually try to go in order where I try 1, 2, 3, and so on and so forth. So I kind of skipped over trying 3. So 3 times what is 36? That's going to be 3 times 12. So let me give myself a negative. Negative 3 times 12 is negative 36. Negative 3 plus 12 is positive 9. So I found my match. So I'm going to go ahead and write my product of binomials. So two binomials being multiplied by each other equals a quadratic trinomial. So last but not least, let's see what happens when we want to try and factor a trinomial with two variables. And what you're going to find out is that if we follow the same pattern and we find two items that multiply, two numbers that multiply to equal negative 55 y squared, they're going to add up to equal 6xy. So we're trying to multiply to get negative 55. We're going to have them add up to be 6. And we have this x in here at the beginning. So they're going to add up to be 6xy, even though the x isn't going to be part of our multiplication. So let me see if there's a better way to show that. So they have you in the notes or from the textbook, they have you sort of just ignoring the variables. Just ignore the variables for now and find two numbers that multiply to equal negative 55 that add to equal 6. And so I can do 1 times 55, but I know that is not going to add together to equal 6. So the only other things I know of that equal 55 is 5 times 11. But that equals positive 55. So I'm going to go ahead and put my negative in there. Negative 5 times 11, negative 55, negative 5 plus 11, positive 6. Look there, I got it on my first try. So here we go when we're writing our binomial. We're just going to have to remember we have our x's, because x times x gives me x squared. And my final term is going to have a y in it, because y times y is what will give me that y squared. And I'm going to go minus 5 plus 11. And so if I were to check and work backwards and check my answer, and working backwards from factoring is just foiling, I can go x times x is x squared, x times 11y is 11xy, negative 5y times x is minus 5xy. Remember, standard form, you put your variables in alphabetical order. And then minus 5y times plus 11y is minus 55y squared. So if I combine like terms, I end up back with what I started, which is how you know if you did it right. So now it's your turn. Go ahead and factor the last problem and make your table and your guesses. And after you've paused the video, check back here for the correct answer. So I'm looking for two things that multiply to equal negative 27. So this is my multiplication column, and two things that add to be positive 6. So 27, I can do 1 times 27, and I'll make one of them negative. So that's going to add up to 26. So that's not going to work. So as I'm counting up, 2 doesn't go into 27. So now I'm going to do 3. 3 times what is 27? That'll be 3 times 9, and I better make one of them negative. Negative 3 plus 9 is 6. So I found my pair. And now I'm constructing my binomials. I've got a minus 3 and a plus 9. Excuse me. So, in summary, we learned how to factor quadratic binomials. By asking the question, by asking what multiplies to equal c, and adds to equal b. Thanks for watching.